Your test tomorrow will have 16 questions total. The first question will give you one of the things like sine, cosine, or tangent and ask you to find the other 5 trig ratios. It's very similar to number 1. So number 1 on the review matches number 1 on the test. Numbers 2 and 3 on the test say find the value of x for the right triangle. 2 and 3 on the test are like 2, 3, and 4 on the review. Numbers 4, 5, and 6 on the test ask you for one positive and one negative coterminal angle, which on the review is like 5 through 7. So again, on the test, 4, 5, and 6 are like 5, 6, and 7 on the review. 7 and 8 on the test ask you to convert the degrees to radians or radians to degrees, which is like 8, 9, and 10 on your review. So 7 and 8 on the test are like 8, 9, and 10 on the review. Number 9 asks you, given the angle and radius, find the area of the sector and arc length. That is like the one found on page 531, number 13. (10) and 11 ask you to evaluate the 6 trig functions, just like 11 and 12 on the review. So 10 and 11 on the test are like 11 and 12 on the review. 12 and 13 ask you to evaluate the function with exact values. On your review, you didn't really have any of those. You kind of did, but not really. Kind of meaning when we did the unit circles and all those things, those were exact values. I wasn't allowing you to use like decimals and stuff like that. This is where we're going to use the unit circle in order to come up with our answers, like that half sheet of paper I gave you guys. 14 and 15 on the test, and I know you only had to do one of them, but it's like 14 and 15 on the review. I know we didn't assign you number 15, but it's like one of those two. That one is the sine and cosine curves where you told me the amp and the period, described the transformations, and then drew a picture. Now, there's still 2 of them on the board. Okay? And number 16 is like number 16 on your review. It's finding the height using the trig ratios. And the trig ratios that you're going to use are the ones that are behind me. Now, all that stuff, just so that you guys know, will be gone tomorrow. That's why you get a note card. Now, here's the other option. And I've told this to every hour, so I'll make sure you guys are aware of it. That unit circle that I gave you, whenever that was, last week or the week before, that half sheet of paper, if you want to put your note card on the back of that, so you only have one piece, be my guest. That would be just fine. If you can't handle that, then make sure you make a note card on a separate, and then you can use, either way, you get to use that half sheet of paper of the unit circle that I gave you. Free of charge. And then it's whether or not you want to make your own note card, or you can put your note card stuff on the back of that. Do you guys know what I'm talking about with the half sheet? It was the unit circle that had all the different ordered pairs and stuff. You are more than welcome to use that. And if you want to make your note card on the back of that, go ahead. There's more than enough room there. Okay? So those things are things that you can use tomorrow, like always. Okay? Does that make sense? All right. We're going to go through as many of these as possible. I will reference them again as we're going through them as to which type these would look like. I'll also explain some tricks and whatnot to help you out, hopefully. Will we get through every question? No. I hope so, but I kind of doubt it. Okay? So that being said, number 1 says the sine of theta is 4 over 9. Right? No, 2 over 7. Looking at the wrong one. That's not up? Sorry. Okay? So the sine is 2 over 7. When I give you the sine ratio, here's something that you can think about. I'm going to put that in the directions, and then in the test it has the chart. Remember how I had that chart for the little mini quiz you guys had? You had to fill in all 6 parts. Sine, cosine, tangent, cosecant, secant, cotangent. I'm giving you 1 out of 6. Giving you a free point. All you got to do is write it in. Okay? Then you need to find me the cosecant, the cosine, the secant, the tangent, and the cotangent. So if I just filled that in right now, I would have 1 out of 6, which isn't very good. So let's fill in some other pieces. If I flip it over right away, what would I get? 7 over 2. So I'll put that in red so you can see it. 7 over 2. Hey, you just got a free number, another point. Just by flipping it over and putting the one that it matches with, that is another point. Now here's something else that I want you to think about. With the sine curve, sine is opposite over hypotenuse, correct? So what number is in the opposite position? 2. Which means everywhere on those ratios I have opposite, I can put a 2. What number is in the hypotenuse spot? 7. Which means on the other ones, I can put 7 in for the hypotenuse. How much have I filled in now?
Everything except for the adjacent.
Everything except for the adjacent. Exactly. Right now, if I gave you a half a point each for those because you've got half the ratio, you're at 4 out of 6 without having to do anything. 4 out of 6 is passing. Okay? If you think of it that way. And have I done anything yet? No. Now, something that I did change up there today is I put the Pythagorean theorem in more terms of this problem. Above all the ratios that I have up on the board, I had x squared plus y squared equals r squared. I had a squared plus b squared equals c squared. But even above that, I put the opposite squared plus adjacent squared equals hypotenuse squared. I put it in terms of this problem for them. So I'm giving that to you too. If you guys want to use that, great. It's 2 squared plus I don't know squared equals 7 squared. What's 2 squared? 4. What's 7 squared? 49. In order to solve for a, we're going to subtract 4 to both sides. What's 49 minus 4?
45.
Good. So I have a squared equals 45. Then how do I get rid of the square? Root. When you square root that, remember you have to break that down. So 45 broken down. 3 goes in there 15 times. 3 goes in there 5 times, and 5 goes in there once. I got a pair of 3's and a root 5 left over. So what did I just find by doing that? The adjacents. So if I put them all in blue, I just found 3 root 5 goes here, 3 root 5 goes there, there, and there. So that's what I found by doing all those. If I left the problem this way, I would give you a 5 out of 6. Why would you not get full credit for this one? Can't have the square root on the bottom. Very good. Nice answer. So right now, if you left it this way, you'd be at an 83%, which is a bottom B. Still B, right? Now, which two do I have to change? Secant and tangent. In order to get rid of the root 5 on the bottom, you multiply it by root 5. What you do on the bottom, you do on the top, and so on. What's 7 times root 5? On the bottom. What's root 5 times root 5? 5. And what's 5 times the existing 3 that was there? 15. So my answer for that one simplified would be 7 root 5 over 15. Be careful with that one. That's kind of tricky. What about the tangent? What do I have to do? Same thing. Multiply it by root 5 to the bottom and the top. So I end up with 2 root 5 over what? Over 15 again. Because root 5 times root 5 is 5, and 5 times 3 is 15. That's number 1 in the review. As a reminder, number 1 in the review is a lot like number 1 on your test. Okay? Now, for the next parts, 2 through 4, which one do you want me to do for sure? Gage, pick a number from 2 through 4. 3. Okay, thanks, Gage. Now, the reason why I asked Gage to pick me a number between those two, or between those 3 problems, it doesn't matter. They're all the same. Now, what you're going to use is you're going to use sine, cosine, or tangent. Somebody asked me yesterday, why can't I use cosecant, secant, cotangent? The quick answer is find those buttons on your calculator. They don't exist. Sine, cosine, and tangent do. So that's why we use those. Now, the other thing that some people were struggling with yesterday was this. What angle are you going to come from on this problem? What angle did they give you?
30 and 90.
They gave you a 30 and a 90, but the 90 is not usable. You have to go from the other one. So if you're going to start at the 30, figure out how these pieces are related. If you go through the triangle, that is opposite. And if you're right next to the angle, it's either adjacent or hypotenuse. But which one's the hypotenuse? Across from the 90 or the longest side, which is not what I have. So according to what I have, am I going to use sine, cosine, or tangent? Tangent. Why? Because I have the opposite side and I have the adjacent side. That's the 100% the reason why I'm using tangent. Now, when we did these problems, I gave you a shortcut with this. And you guys saw it pretty well then, and I'm sure you probably see it now, but you may have forgotten it. And what that is when you're trying to find the missing piece and it's on the top, you multiply the two things that you have together. What's 12 times the tangent of 30? 6.93. Depending on how many places you round to, that would be it. What do you think? Do you want me to do another one like that? What? Do you want me to do another one like 2 or 4? Okay? Just know that on your test, there are 2 that are like that, where you have to decide which one of the big 3 you're going to use and solve for x. Okay? Well, yeah, we'll get there. On 5, 6, and 7, it says draw the angle given, then find one positive and one negative coterminal angle. You have 3 of these on your test. Okay? These should be some of the easier questions we have. Now, I'm going to for sure do 5 pi over 6. And I was also asked to do number 7. So those are the two that I'm going to do. I'm going to do 6 and 7. Well, first of all, for drawing this angle, is this angle on your unit circle I gave you?
No.
Yes, it is. If you look at the unit circle, Andy, I know you have yours out. Where is it? That's at 150. Now, if you weren't sure about that, could you have converted it to degrees? Yes. Sure, we'll talk about that here in a little bit. But that 5 pi over 6 should be there. Also, should have a little mark like that so that it shows that it opened up. That's the drawing. As far as the one positive and one coterminal angle, when we did this one in your assignment, we converted it to degrees. Then we added and subtracted 360, and then we converted back. I'm going to show you a little trick to save yourself some time. On your unit circle, what does 360 equal in radian measure? On your unit circle, 360 matches with 2 pi. So instead of me converting it to degrees, adding and subtracting 360, then converting it back, I'm going to take 5, 6 and add 2 pi to it. Because 2 pi is the same as 360. Now here's the nice thing. Your calculators will do this for you if you type it right. Realistically, I do not care about the pi just yet. I'm really taking 5, 6 plus 2. So on my calculator, I'm going to take 5 divided by, turn it on, 5 divided by 6 plus 2. That's what I typed, right? And I hit enter. And it came out with 2.83333333. How can the thing put it back into fraction mode for me? Do you remember? I can math and frac it. Ba-dum. And what number did I get for a fraction?
17 over 6.
17 over 6. And then just put the pi down with it. Did it all with my calculator. Now, if you don't want to use the calculator, I get it. If you put the 2 over 1, this goes back a long time in your educational careers. How do you add and subtract fractions? Right. A common denominator is needed. What's a common denominator between 1 and 6? 6. So you'd multiply this by 6 and this by 6, which would give me 12 over 6. And then you add the tops. What's 5 plus 12?
17
over
6.
Same thing I got with the calculator, right? Now, if I take 5 pi over 6 minus 2 pi, again, I could do the calculator. 5 divided by 6 minus 2, enter, and then frac it. Or, you already know what the common denominator was. You told me that. What's 5 minus 12? Negative 7 over 6. Did you give me one positive and one negative? Yes, you did. That's all you need to do. Number 9, I think, right? 7, sorry. Number 7 has negative 960 degrees. Now this one's a little unique because of the fact that it's not less than 360 to begin with, is it? So when I draw this, first of all, which direction do I turn it? Do I turn it clockwise or counterclockwise? When it's a negative, I go clockwise. Now, the key to this one is I'm going to turn this more than 360, right? So count with me. 90, 180, 270, 360. Do I need to keep going?
Yes.
450, 540, 630, 720. Do I need to keep going?
Yes.
810, 900, probably about here-ish, right?
Yeah.
And that would be negative 960. Just be careful not to stare into the spiral too long, otherwise you'll be hypnotized. Just tease it. Now, one positive and one negative one. Here's the trick. Negative 960. If I add 360 to it, what number does that give me? Negative. Negative 600. Is that positive yet? Nope. If I add another 360 to it, what's negative 600 plus 360? How much? Negative 240. Is that positive yet? Nope. If I add 360 again, what do I get? Positive 120. I found my first positive answer. Great job. Then it wants you to have one negative one, doesn't it? Do I have a couple negative ones to choose from? Yeah, I do. I have either the negative 240, the negative 600, or if I went the other way and took negative 960 minus 360, I'd have negative 1320. That's okay too. As long as you have one positive and one negative. That's all that matters. How do you guys feel about those? 3 pi over 10. Is that in radians or degrees? Ronnie, why is this in radians? It has pi. Awesome. If you are converting from radians to degrees, you multiply it by 180 over pi. When you're doing that, what happens to the pi? Somebody ate it and it's all gone. And it wasn't me. What's 3 times 180 divided by 10? 54. A close only counts in horseshoes and hand grenades. Negative 60 degrees. Is that in degrees or radians? Degrees. So if it's in degrees, I multiply it by pi over 180. Then if I multiply straight across, what's negative 60 times pi? And what's 180 times 1? Now reduce it if you can. By the way, if you want to reduce it beforehand, that's your choice. Negative pi over 3. Don't forget the negative sign. Got to keep going. So for this particular problem, again, I did 8 and 9. I'm not going to do 10 because it's the same thing. But you have 2 of them like that on your test. I'm going to skip up now and do page 531. What number did we do on 531? Number 13? 13. What you need to do, page 531, number 13, is you need the arc length, which is the radius times theta, and you need the area, which is 1/2 r squared theta. When we did this problem before, or one like it, we were talking about fencing in a softball complex. This is number 13 on page 531. This is like number 9 on your test. They give you that the radius is 13 and the degree, or the theta is 40 degrees. Now the problem here, you guys, is You're not allowed to use degrees when you're finding this. You have to put it in radians first. So what do you got to do? Multiply it by pi over 180. Now here's the catch, which I hope you guys can understand, is if I have 40 pi over 180, I can reduce it if I want to down to 2/9. But if your calculator is going to do the work anyway, what does it matter? Does it? No. Leave it as 40 pi over 180 because your calculator will handle it all for you anyway. Okay? The radius for the problem that they gave you was 13. So to find the arc length, you take 13 and you times it by 40 pi over 180. Your calculator has a pi button. Do you know where it is?
Yes.
It's above the caret button. Right. Now, the reason why this is okay here is because in this context, we're saying the length is going to be so long. You're not going to walk around and go, I really need 26/9 pi feet of fencing. That doesn't happen. Okay? So what happens here is we just type that all in and see what comes out. So I type 13 times 40 pi divided by 180, and I got 9.08. All I did was type it in as it looks. Same thing with the area. 1/2 times 13 squared times 40 pi over 180. Type it all in. See what comes out. What'd you get? So about 59, because it's like 58.99, right? So about 59. Whatever's squared. If it's inches, feet, miles, meters, whatever, you square it after that.
I hope it would be
I think it was inches, actually.
That'd be a big compass.
Okay? What do you guys think about that? You have one like that on your test. You gonna be okay? Then, number 11.
Can you go back to that? Okay.
Got it? Number 11 has this ordered pair down here at -2, -6. Bless you. Is this a unit circle? No. The reason why it's not a unit circle is because of what Gage put up there on the scale. And that was that the radius was always 1. The radius is not 1 in this problem. To find the radius, we need to take x squared plus y squared equals r squared. What's the x coordinate? What's the y coordinate?
So it's 4 plus 36 equals 40.
4 plus 36 is equal to 40.
Yeah,
Now what?
square
Root
root.
it.
But there's no definition.
The square root of 40 does not come out evenly, but can you reduce it? 2 goes in there 20 times. 2 goes in there 10 times. 2 goes in there 5 times. And 5 goes in there once. I got a pair of 2s. A 2 and a 5. What do I do with the 2 and the 5? And they stay inside. So there's your radius. When you're making your 6 trig ratios, we did one like it at number 1 where we had opposite over hypotenuse, stuff like that. When we did this problem then, that's why I put y over r. x over r. This is the y coordinate divided by the radius. X coordinate divided by the radius. That's all it is. So if I'm going to do sine, what's the y coordinate? -6. Divided by, what's the radius you just found? 2 root 10. Now, bad news for you. Can you have root 10 on the bottom? Nope.
-6.
So you multiply it by root 10 to both top and bottom. And you end up with -6 root 10 over what?
1,
Over 20. How'd you get 20?
2 times 10.
Root 10 times root 10 is 10. And 10 times the existing 2 is 20. Good job. Now if you leave it like that, I'm still marking half wrong. Because you didn't reduce the fraction. What can I divide both the 6 and the 20 by? 2. And what do I get? And don't forget the root 10 too. When you're going to find the cosecant, you flip the sign over. But I'm going to show you in blue. I would flip this one over right here. The reason why I'm going to flip that first one over is because it's less work for you to do then. Promise. Okay? If I flip the 2 root 10 over -6 over, that's a lot less work to do. If you flip over the end result, you still have that root in the bottom. Can I reduce that? By what?
2.
Awesome. What's 2 divided by 2? Nice job. Now, I put root 10 over -3. If you put negative root 10 over 3, that's fine. As long as you have a negative in there somewhere, I don't really care. Cosine, according to the chart, is now the x coordinate over the r. What's the x coordinate? -2 over 2 root 10. Once again, can you have root 10 on the bottom? No. So I end up with -2 root 10 over 20. Can I reduce that? Yeah. And if I do, I get negative root 10 over 10. Oops. The secant, again, if I leave it in blue, flip this one. So you end up with 2 root 10 over -2. The 2's cancel, leaving in negative root 10. Now, I know those weren't the most user-friendly problems. Now the easy two come. Tangent was y over x. What's -6 divided by -2? 3. 2 negatives make it a positive. And if I flip that over, what's 3 flipped? Not negative. Kind of in the middle. Becca. I just ran out of room. What's 3 flipped? Or the reciprocal of 3? 1 over 3. Not a very user-friendly problem. With all the roots in there especially. Okay? $12. Is this one a unit circle?
Yes.
Yes. No ordered pair. It gives you an angle. So this would be the unit circle. This is what the piece of paper is used for. I am right here at this angle right here. What ordered pair is that angle? 0, 1. Becca, what is the radius for any unit circle? 1, as Gage so graciously put on our scale. The sine curve, I always say curve, the sine ratio is the y-coordinate. What's the y-coordinate here, you guys? 1 divided by the radius, which is? What's the radius? 1. And what's 1 divided by 1?
1.
If I flip that over,
It's still 1.
it's still 1. The cosine is the x-coordinate. What's the x-coordinate?
0.
Divided by the ratio. No, not ratio, radius.
Over 1.
What's 0 divided by 1? If I flip that,
Undefined.
undefined, I cannot have a 0 on the bottom. Tangent is the y-coordinate divided by the x-coordinate. What's 1 divided by 0? Undefined.
And then 0.
And cotangent, if you flip it, becomes 0 divided by 1, which is 0. Now, on questions 12 and 13 on your test, you didn't specifically have one exactly like that on your review. Okay? What those would look like is it would look like the tangent of 150. I'm just asking you for one of the pieces out of the 6. I'm not asking you for all 6. You had to do all 6 on 1, on 10, and 11 on your test. 12 and 13, just want you to find one piece. You still use the unit circle. With your piece of paper that I gave you, 150 degrees has what ordered pair attached to it?
Add pi over 2.
That's not an ordered pair.
Oh, negative 3 over 2.
And?
1 over 2.
Okay, you need the ordered pair. Gage, what's the radius for this? 1. Awesome. The tangent is the y-coordinate. What's the y-coordinate for the ordered pair that you just gave me?
1
Divided by, what's the x-coordinate?
negative 3 over 2.
When you're dividing fractions, remember you're multiplying by the reciprocal. What's the reciprocal of negative root 3 over 2? Good. What happens to the deuces? They cancel. So if I multiply straight across, you're left with 1 over negative root 3. Are you allowed to have root 3 in the bottom? No. So how do I get rid of it? Times it by itself. And what you do to the bottom, you got to do the top.
So 1 root 3.
So 1 root 3 over
Negative 9.
negative 3. Because root 3 times root 3 would be root 9 or 3. Okay? You have 2 of them that are like that on your test. Then, 14. Has g of x equals 3 sine of x. And it says, identify the amp, the period, and any transformations. Then sketch the graph. You have 2 of these. What's the amp for this problem?
3.
3. How'd you get that?
It's the first number.
It's the first thing you see, first number.
The period is 1 and there's no
2 pi is the period. Because remember the formula is 2 pi divided by the b. And the b is 1. Is there any transformations? No. So then if I draw my axes, you said the amp was 3. So 1, 2, 3. 1, 2, 3. You also said that the period was 2 pi. What's half of 2?
1, so pi,
What's half of 1?
0.55.
What's 0.5 plus 0.5 plus 0.5?
3/4.
3 seconds.
Not 3/4. That would be 0.25. 0.5 plus 0.5 plus 0.5. Now, sine curve. The sine curve start at the midline or the amp? Middle. Then where does it go? Up. If it's negative in the front, it goes down. But if it's positive in front, it goes up. Where's the third dot go? Midline. Where's the fourth dot?
Down.
Bottom. And what's the fifth dot?
Up.
Back to the mid. Connect the dots. You will have 2 of those to do. Then the last one I'm going to help you set up is 16A. You are flying a kite at an angle of 70 degrees. So here you are standing, flying a kite at 70 degrees. You have let out a total of 400 feet of string.
And you're 4 feet off.
And you're 4 feet above the ground. Part A says find the height of the string. So out of sine, cosine, or tangent, which one are you going to use? Why are you going to use sine? Because you have opposite and hypotenuse. Good. So the sine of 70 equals x over 400. Are you going to multiply or divide in this situation? Multiply. And when I do that, taking 400 times the sine of 70, I end up with 375.9. However, I also have to add in the 4 feet that you are above the ground. And I get approximately 379.9 feet. Or if you were to tell me 380 feet, I would give that to you. So again, make sure you make your review, your note card. You can make it on the back of your unit circle if you want. If you did today while we were doing this, great. Now make sure you practice some of it. Make sure you know how to do it. That's your assignment.
I hope you're